Alrighty. So grades have been updated for everyone. Lesson 6.5 will get updated soon. Yes, I saw the request for lesson 6.5 late quiz to get put on there. I'll do that by the end of the day today, as well as 6.5 for those of you that did it on time will be put on by the end of the day today. Lesson 6 or exam has also been imported. There's several of you that still haven't taken exam 6A. Y'all need to hurry up and get caught up. 6B is on Wednesday. Okay. Alrighty. So what we're doing today. No, they won't. They won't have it. No, don't bring me down like that, Angel. Why are you doing that to me, huh? We don't have school Friday, right? No, that is officially the start of our spring break. Okay, which is why you have an exam on Wednesday. So that way a whole week doesn't pass by and then you have an exam when you come back. I'd rather you take it before. Anyway, so today we're going to be doing inverse functions, okay? So before we start talking about inverse functions, we need to remember, what does inverse even mean, okay? You've been doing inverse since you were younger, okay? You just don't really hear it a whole lot. So let's talk about a few inverse that you already use, right? So you already use inverse operations, right? So this is just a mini review so our mindset can get ready for what we're about to learn today. So inverse operations, right? So for example, the inverse of adding is what? Subtracting, right? That is the inverse of adding. Why? Why are they inverses? Because they undo each other, right? So if I have a positive 1, I'm going to subtract 1, right? So a positive 1 and a negative 1 cancel out. It gives a 0. A positive 3 and a negative 3 cancel out. They give us 0. Negative 10 and a positive 10 cancel out. It gives us 0. Adding and subtracting are inverses of each other, okay? Now, what about dividing, right? What is the inverse of dividing? Multiplying, right? And why is that? If I have a positive 10, you divide, or you can, so there's two ways we can see this, right? How can I, okay, so 10, you can multiply by 1 over 10, right? And that's going to give you 1. Or another way you can look at that is you can do 10 divided by 10 is 1, right? So if you have 2x equals 5, what do? The inverse, because you're multiplying, you divide by 2, right? And that gives you 1x and then whatever, right? Or if you have 1 over 10x equals, I don't know, 2, well, because you're dividing, what would the inverse be? You multiply by the reciprocal, which is 10. Why do we multiply by that? Because 10 times 1 over 10 is 1x, which is what you want, right? So inverses basically means to undo and go back to the original. When you're adding and subtracting, that's 0. When you're multiplying and dividing, the goal is 1, okay? So just pre-knowledge. All right. Now, what does that have to do with inverse functions? Okay, because you have to understand what inverse even means in order for you to start to understand what we're doing. Okay, so basically, I want to go back to the original. Okay, so what is inverse? So two relations, right? So not necessarily a function, just a relation. Two relations are inverse if and only if one relation contains the elements AB and the other contains BA. So first of all, well, what do you notice? Between AB and BA, what happened? They what? They switched, right? Do y'all see that? Okay. So the first thing we're going to do is, are the following relations inverse? Plot the points and describe what you notice. Use 2 different colors if you can, because it'll help you see what we are looking for, okay? So 2 different colors if you can. Okay, so the first color, I mean, I really don't care. I'm just going to do purple. So for A, I'm going to do purple, right? So we have 2, 1. So 2, 1 is about here. Then we have 4. So this is, I guess, A, B, C. So then this is A. And then we have B at 4, -3. So 4, -3 would be about right here. This is my B dot. And then C is at 5, 1. So 5, 1 would be about here. So this is my C, right? So we have A, B, C right there. So now I'm going to choose a different color. Let's go with green. And I'm going to do B. So I'm going to do my data from set B in green. So we have 1, 2. So 1, 2 is right here. So we're going to label this one A prime, right? So A prime, B prime, and C prime. And then -3, 4. So 1 and 2, -3. And then +4 would be about here. So this is going to be my B prime. And then C is 1, 5. So 1, 5, which would be right here. Okay, what do we notice? So look at the two different colors and kind of look at the two different shapes. Kind of tilt your head a little bit like this. What do we see? What do we notice with our two different colored dots? Yeah, but like, tell me what you see without using the word inverse. It's what? It's like going clockwise. Yeah, what would we call that? Like if it's like, think of a word that describes it. It doesn't have to be mathematical. So just look at what we see. It's rotating. Kinda. So think of a different word. You're going towards the right path. Moving. Mande? Moving. Keep going. Crossing. It's kind of crossing, right? But instead of crossing, what's another word I could use? Reflecting. It's reflecting. Now, what is it reflecting over, right? Because it's not reflecting over the x-axis and it's not reflecting over the y, right? So what's happening here is that these things are inverses of each other because they are reflecting that line. Do you see how when I draw that line, they are reflecting across that line? Do y'all see that? Okay, this line is y equals x. Isn't that the most simple function you could possibly think of, right? Y equals x is the most basic function. It's the original. Okay, so any two things are inverses of each other if it's reflecting across y equals x. Okay, so for number 2, so are the following relations inverse? So this one is yes, because the points from set A reflects across y equals x from set B. So you'll notice right here, that's why I labeled them A, B, C, and then A prime, B prime, C prime, right? So you can see that purple dot A is reflected across y equals x as A prime. Purple dot B is reflected across B prime. And then label dot C is reflected across, oh, I forgot to label this one. And then here's, oh, ya se me está muriendo. And then here's C prime. Okay, so each dot, you can see that it's reflected across y equals x. So if you have two equations and you're not sure if they're inverses of each other, you can graph them. And if they're reflecting on each other across y equals x, then they are inverses of each other, which basically means that they undo each other. They're opposites of each other, right? Adding and subtracting is opposites of each other. Multiplying, dividing are opposites of each other. So if two functions reflect across y equals x, then that means they're opposites of each other. So if you put them together, they would just cancel out and give you y equals x or give you x. Okay, so 2. So again, let's use two different colors. So let's do A, right? So we have 3, 2. So 3, 2 would be here. 4, -5. So 4, -5. 6, 1. So 6, 1. Okay, so let's do A, B, C. So 3, 2, so A, B, C. Okay, and then for the next one, negative 3, 2, 1, 2, negative 3, 2, 5, negative 4. So 5, negative 4 would be about here. And then 6, 1. So 6, 1, which would fall on top of this one. So A, B, C, D, E, F. So D, E, and then we'll make this one F, which is really just C, but okay, whatever. Now, are they inverses of each other? Is this data inverses of each other? Nah, it's pretty plain and simple, right? If they don't reflect across y equals x, they're not inverses. Another way you can tell, obviously, if you look at problem number 1, I color coordinated, right? Because I wanted you to see how the dots, literally, they just flip from each other, right? So these right here, 2, 1, 1, 2, they switch places. These switch places and these switch places. So that's another way you can tell, right? So on number 2, you can tell that 3, 2 and negative 3, 2, they're not switching places. So you didn't even have to graph it. You could just look at the data and it is no, because set A comma B does not equal set B comma A, right? Which basically means the coordinate pairs aren't switching, right? And data or points do not reflect y equals x. So I gave you 2 reasons that this is not an inverse relation. Okay, so that's an inverse relation, right? Which means that they're just random dots that I chose, and I'm checking to see if they're inverses of each other. So inverse functions, this is where we're actually going to get into our real lesson, right? So inverse functions are 2 functions that are relations of each other across y equals x, which is pretty much what we just talked about, right? So the inverse of f of x is written as f of, I don't know how to really say that. That's a good question. I just say inverse of x, okay? Or inverse of the f of x, all right? So how to find the inverse of a function? It's really not that hard to find the inverse of a function. It can get a little complicated the harder the equations are, but obviously it's our first day, so it's not going to be that bad, okay? I like it, okay? But I mean, there's not a lot of things I don't like about math, so yeah. All right, so step 1. You're going to change f of x or g of x or whatever of x, okay, to y. Then we're going to switch x's and y's, and we can see why, right? Because AB has to be this, in order for them to be inverses, AB have to be able to flip, right? So that's literally all we're doing, is we're going to flip x and y. Then we're going to solve for y, and then change y back to the inverse notation. So literally, you're just switching and solving for y. That's it. Okay. So now to verify your work, right? The theorem states. So remember, we did compositions not that long ago, right? Like our last lesson. So if you have f composed of the inverse of f of x, it has to equal x, and you have to be able to do the same composition, but with f of the inverse of f first, and then x. Now, I rewrote it right here in the other notation, right? So basically, you're going to put the inverse function inside the normal function. And then for the second one, you're going to put the normal function inside the inverse function, which sounds a little complicated, but I mean, it's been a while, so I'm sure it'll refresh y'all's brains once we do it. Okay, so here we go. Nah, you should have had your inverse done. You're going to have to do it on your own time. Okay, so inverse functions, number 3. Okay, so that's the one we're going to do now. Hold on, let me make sure. Okay. Alrighty. So given the functions below, determine the inverse functions, right? So I want to know the inverse function. So I am looking for the inverses of all these functions, right? So 3, we have f of x equals 2x plus 8. Okay, so step 1, we're going to change f of x to y. Step 2, we're going to flip them, right? So I'm going to change X here, and then I'm going to put the Y where the X was at. So step 1, change f of X to Y. Step 2, flip them. Step 3 is going to be solve for Y. So here's my Y, right? So I'm going to subtract 8. So X minus 8 equals 2Y. And then divide everything by 2. So Y equals X minus 8 divided by 2, or, right? Or you can simplify that to Y equals 1/2 X minus 4, because there's a 1 right here. So that's 1 over 2X, and then negative 8 divided by 2 would be negative 4. Now, which one do I prefer? I prefer the bottom one, but they're both correct. I prefer slope-intercept form, right? So that means that my inverse function, remember, you have to put it in inverse notation. So f of that little negative one at top of X, so my inverse function is 1/2 X minus 4. So the inverse function of f of X, 2X plus 8, would be f of inverse of X, f of inverse X, 1/2 X minus 4. Now, how could you check your work? We're not going to do this, right? Because it would take forever, but you could always check your work, right? By doing the composition of these, right? Which means I could take f of the inverse of X, and you would have to check if you take the inverse and plug in the function, both of these would have to give you X. Oh, I forgot to write it in this column, just so that you can see both formats. Remember, both of these things mean the same thing. I just wrote it in both forms, but they would both have to give you X. And we're going to be doing a lot more of that on the next page, so you'll be able to see what I mean by that, okay? So number 4. All right, so my first step is to change g of X into Y, right? So instead of g of X, I want Y. Then I'm going to flip my X and Y. So I'm going to put X here and then 1 over 3 Y there. And now I'm going to solve for Y. So I'm going to subtract 7 to both sides. So that's X minus 7 equals 1 over 3 Y. I have a fraction, right? The inverse of division is to multiply. And that's 1 over 3. So I'm going to multiply by 3 over 1. So I'm going to multiply this side by 3 over 1, which is just 3. So we're going to have 3x minus 21 equals y, because these cancel out. So we have the inverse g equals 3x minus 21. So this would be your answer. Okay. Do y'all want to try number 5? Because we only have a few minutes before lunch. Y'all want to try number 5? Go. Let's see how far y'all get. Go on ahead and try number 5. I'll give y'all 27, 28, 29, like 2 minutes, and then I'll quickly go over it and then let y'all go to lunch. Okay, so going over this one, obviously h of x, you're going to change it to y, and then you're going to flip it. So this is going to be x, and then this is going to be y squared plus 6, right? So then you want to solve for y. So you're going to subtract 6 to both sides. So x minus 6 equals y squared. Y squared is not isolated. It has to be only one Y. So what is the inverse of a power of 2? What is the inverse of an exponent? The root symbol, okay? So anything to the power of whatever, all you have to take is take that root of it. So we're going to square root it because it's going to cancel out. So we're going to have Y equals the square root of X minus 6. Now, all we have to do is change this Y back to our inverse function notation. So the inverse of H of X is going to be the square root of X minus 6. And then that would be your inverse function of this one. Okay, go to lunch. Okay, go on ahead and do number 6. And let's see how we do. Nah, you're doing number 6 right now, so write it down. Give yourself room. This is why you should have your outline ahead of time. Go, do number 6. I'm gonna call on you and see what you get. Follow the steps. That's why you're trying.
Pizza smells awful.
What? Hater. It was delicious. Except for that Hawaiian one they got, but work. Okay, when you get your answer, type it in the chat. Okay, let's go on ahead and do it. So we have, y'all were close. Y'all missed it by the mark just a little bit. Oh, that one's good. Okay, so obviously we change mx to y, then we flip them, right? Or we switch them, we swap them, and then now we're solving for y. So this is just solving equations, right? So the first thing we're going to do is get rid of the denominator of 5, and we do that by multiplying by its inverse. So multiply by 5 over 1. So that means we're going to multiply the other side also by 5 over 1, which is really just 5. These 5 cancel each other out. So we have 5x equals 2y minus 3. The inverse of subtracting 3 would be adding 3. So we're going to have 5x plus 3 equals 2y. The last step here would be to divide by 2. So y equals 5x plus 3 divided by 2. Or y equals 5 over 2x plus 3 over 2. These are the same, right? So then the last step is to show that that is the inverse. So this would be the inverse mx equals, and you could use either one, right? So I'm going to use, I guess it doesn't matter. So 5x plus 3 divided by 2, because that's what I use. I don't know, just because they're both fractions. So then this would be your answer. Number 7, literally same thing. Y'all should be able to do number 7, but to get it going, I'm going to go ahead and work through it. So we know that this is y equals negative 4 over 3 x plus 2. Step 2 is to flip my x's and y. So x equals negative 4 over 3 y plus 2. Solve for y. So we're going to subtract 2. So we're going to have x minus 2 equals negative 4 over 3 y. To get rid of a fraction, remember, you just multiply by its reciprocal. So that means that I'm going to be multiplying both sides by 3 over negative 4. So that means I'm going to have to multiply this side by negative 3 over 4. So these reduce to y. So y equals, I'm going to go on ahead and distribute my negative 3 over 4 to both sides. So negative 3 over 4 x. Negative and a negative is a positive. Negative, and then 3 times 2 is 6. So it's 6 over 4, and 6 over 4 simplifies to a positive 3 over 2. So we did 3 over 4 times 2 over 1, which is 6 over 4, which simplifies to 3 over 2. So the inverse of P of x is equal to negative 3 over 4x plus 3 over 2. Okay, for the last one, same thing. So that we have y equals, right? So we know this is really y. So then I'm gonna switch everything. So x equals y minus 3 cubed minus 4. So here we switch. Here we switch. So we have y is inside the parentheses. So this is just like anything that we've ever done, right? So you want to isolate the y. So before you can do that, you have to move the minus 4. So we're going to add 4 to both sides. So we have x plus 4 equals y minus 3 cubed. So we have parentheses to a power of 3. So how do we get rid of the power? What would I have to do? It's just like a squared, but it's a 3. So what would we do? So cube root, right? So anytime you have a power, you just have to get that same nth root. So because that's a power of 3, that means that I need to take it to the third root, because that root and the 3 are going to cancel each other out. So since we're doing that to the right side, that means we have to do the same to the left side. So we're going to cube root that entire x plus 4. So now we have cube root of x plus 4 equals y minus 3, because the cube root and the cube cancel each other out, or they're inverses of each other, right? They undo each other. So then now just add the 3. So we're going to have y equals the cube root of x plus 4 plus 3 on the outside. So then the last step is just to convert it into inverse notation. So k inverse of x is equal to the cube root of x plus 4 plus 3. So this would be your inverse function to k of x. Okay, I'm gonna give y'all like 30 seconds to finish writing that down, and then we're gonna move on to determining whether functions are inverses. So basically verifying if they're inverses or not. Okay, so then this part of the notes, right, is I'm giving you a function and then I told you to go find the inverse of it. The next part is I'm going to give you two functions already, and then you have to tell me if they're inverses of each other. Okay? All right. So now, number 9, determine if the functions are inverses. Okay, so the way we determine our inverses is from the notes up here at the top, right? So this part right here, to verify, check if this and that. So basically, in order to know if they're inverses of each other, you have to grab the composition of each one and put it inside of the other, and it has to give you x. And grab the inverse function and then put the original, and it has to give you x. Okay, and it's an if and only if statement, and that basically means that both of them have to be true. Now, usually if one of them is true, the other one's true, but there are examples where one can be true and the other one won't. So yeah, you have to do both. Okay, especially for pre-cal, those of you that plan on going to pre-cal next year. So for number 9, you can see that we have f of x and g of x, right? So in order for this to be true, I need to do both. So we're going to grab, what color should I do this in? Let's do pink. So I need to show that f of g of x equals x, and I need to show that g of f of x equals x. That's what we need to show. Now, remember, we did this for lesson 6.5, okay? I don't know which way y'all preferred. I forgot. So we're just going to do it, okay? So we have f of x and then g of x. So I'm going to start with the outside, or you can start with the inside. We kind of talked about that, right? So on the outside, I have f. And what is f? What is f? What does function f equal? There we go, because you're not 2x plus 6, right? So I'm going to grab the function f, which is 2x plus 6. So do y'all see that part? Do we get that part? Okay. Then I want to grab g of x, and I'm going to put it inside where x is at. Do y'all see that right there, right? And what is g of x? So we're going to have 2, and inside our x, I'm going to plug in g of x the way I see in my parentheses, which is negative 2x plus 6. And we're going to simplify that. And it needs to equal x. If it does not, then I'm done. Okay? So let's simplify. 2 times negative 2x would be negative 4x. 2 times 6. Oh, I forgot the plus 6. My bad. Right? I forgot to write this right there. Anyway, so negative 4x, and then where's my pink? 2 times 6 is 12. And then don't forget your plus 6 from your original function f. And then combine like terms, right? So then we end up with negative 4x plus 18. Is that x? What did I end up with? This is my answer, right? Is that x? No, it's not. So then we know that f of x and g of x are not inverses. So I don't even have to do this one. I don't even have to do it because the first one's already wrong. So that's an example. Thank you. That's an example of what is not inverses, right? So now we're going to see in one of these what is. Okay, so for 10, so we're going to do, right? So we're going to do f of g of x, and we have to do g of f of x. We have to do both. So let's do the first one first. Okay, so go on ahead and set the first one up. 1, 2, so that we can see if you know how to set it up on your own. So I'm going to give you like 30 seconds. Go on ahead and set up f of g of x, which is the first one. So plug them into each other the way we did on the last lesson and see how that goes. And then we'll keep going. No. No. Never when I'm teaching. Sorry. Nope. I'm recording. I don't understand why you're being so annoying. No. Okay. When you're done, just give me like, I don't know, just type something so I know we're done. All I want you to do is set it up. I don't want you to solve yet. Thank you. Okay, so for this one, I'm going to do it the other way, right? So where I start from the inside and then I do the outside because I don't remember which way y'all like more. So if I start from the inside, right? On the inside, I see g of x. So what does g of x equal? Well, g of x equals the square root of 3x minus 3. I'm going to put parentheses around it, and then we have that f. Okay. Then we have f, which is 1 over 3x squared plus 1. But instead of x, I'm going to put this in. This is your x, right? So I'm going to have 1 over 3, and instead of x, I'm going to have the square root of 3x minus 3 squared plus 1. So it doesn't matter which way you did it, you should have gotten what I have right there in green. How many of us did this correctly? Just so I can see where we're at. So it doesn't matter which way you do it, everyone should have ended up with what I have in green. Is that what we got? Type it in the chat. I need to know so I can see how many of you are lost. So I can help guide you towards the right path. Sorry, I didn't mean to sound angry, just passionate. Okay, cool. So then now all we have to do is simplify, right? So we have, you're going to notice that we have a square root and a squared. Are those, do you see that those are inverses of each other? So what happens with the square root and the squared? They what? They cancel each other out, right? So then that means that I have 1 over 3, and I still have 3x minus 3 plus 1. So then we're going to distribute now. So 1 over 3 times 3, you should notice that those are inverses of each other. So you end up with x. And 1 over 3 times negative 3, again, they're inverses of each other. So you end up with the minus 1. And then bring down your plus 1. Well, negative 1 and plus 1, aren't those inverses of each other? So what do we get? 0. So you end up with an x. And this is exactly what you want. Check. We're not done. You have to do it again, but you have to put your original function into the inverse function, right? Which is this second one. So I'm going to give you a few seconds to go on ahead and set it up. I want you to do the composition of number 2, right? This one right here. I want you to do this composition so we can make sure that we're plugging it in correctly. So I'm going to give you about 30 seconds. Go on ahead and do that now. Here, maybe I should be pausing it while I give y'all time to do that. All right, so for this one, to set it up, okay, I don't know which way I prefer, so I'm just kind of going back and forth, right? So on the outside, I see g. So my g is square root of 3x minus 3. That's my g. So I already have my g. Instead of x, I'm going to plug in f of x. So right here where this x is at, I'm going to plug in f of x. And this right here is my f of x. So I'm going to have 1 over 3x squared plus 1 in parentheses, and then just bring everything else down, right? And then square root all of that. So that is what you should have ended up with. How many of us ended up with that? How many of us got that correct? So we're getting better at being able to do composition of functions. Okay. And if you're not getting it, make sure you ask a question, like where are you getting stuck? What doesn't make sense, to help me help you. Okay, moving on. So then now we just have to simplify. So we see that we're going to multiply 3 times 1 over 3 are inverses of each other, right? So that's really just 1x squared. And then we have 3 times a positive 1. So that's positive 3. And we're going to bring down my minus 3. And don't forget, we're square rooting all of that, right? What's next? Well, we have 1x squared. And then you should see that plus 3 and negative 3 are inverses of each other. So what does that give you? 0. So you end up with an x squared. What else should you notice? You should notice that the square root and squared, what's going to happen with those? They cancel each other out because they're inverses of each other. So this square root and that squared also cancel out. So what are we left with? X. So what does that tell me about f of x and g of x? Are they inverses? Yes. So yes, f of x and g of x are inverses. because f of g of x equals x, which is the same as g of f of x, right? They both equal x. Okay. All right. 11. Okay, so remember, we're going to have to do it both ways, right? We have f and g. So we know we're going to have to do f of g of x, and we're going to have to do g of f of x. I'm going to give you 1 minute. Do y'all want to try it on your own and see how it goes? I think you should. I'll give y'all 2 minutes. Okay, so I hit record it. So it looks a little weird. So what I would have done, do you see how g of x has negative 1 over 4 times the quantity of x minus 1? I would go on ahead and distribute that to make it a little easier for me, right? So I would go on ahead and make this into negative 1 over 4x plus 1 over 4. That's just me though. You could have done it without doing that, but I probably would have gone on ahead and simplified that, okay? So then now I'm gonna grab f, right? So my f is negative 4x plus 1. This is my f of x. And then I'm gonna grab g of x and put it inside that x. So we have negative 4 times my g of x is now simplified, right? So negative 1 over 4x plus 1 over 4 plus 1. Do y'all see why I distributed first? It looks a lot prettier, right? Than what some of you may have had. It could have still worked. I'm not saying it wouldn't, okay? But I would have done that first, okay? So then now all I have to do is simplify. So negative 4 times negative 1 over 4 are inverses of each other, right? So that's just a positive 1. Negative and a negative is a positive. So we have 1x. Negative 4 times 1 over 4, again, are almost inverses of each other. Positive and a negative is a negative. And we have a 1. 4 times 1 over 4 is 1, right? Then we bring down our plus 1. Well, what's going to happen with this negative 1 and plus 1? They're inverses of each other, right? So that means we end up with x. So then now we have to go do the same thing, but with g of x. So this time I'm going to grab g, right? And my g is negative 1 over 4x plus 1 over 4. Remember, I'm grabbing the simplified version. I'm not grabbing the parentheses. Then inside this x, I'm going to put f of x right in there. So I'm going to rewrite negative 1 over 4, but instead of x, I'm going to put my function f, which is negative 4x plus 1. And then don't forget your plus 1 over 4 on the outside. So that should have been your g composed with f of x. And then now all we have to do is simplify. So negative 1 over 4 times negative 4, you're going to notice that those are inverses of each other. So we end up with the positive x again, or positive 1x. Then negative 1 over 4 times a 1 is just going to be a negative 1 over 4. Bring down your plus 1 over 4. You're going to notice that negative 1 over 4 and plus 1 over 4 are inverses of each other. So that's 0. So we end up with an x. So are f of x and g of x inverses of each other? Yes, for the same reason as number 10, right? So yes, f of x and g of x are inverses because f of g of x equaled x, which also equaled g of f of x. Okay, number 12, same thing. So remember, we're going to do this twice, right? So I'm going to grab f and I'm going to plug in g of x inside of it. And then I'm going to grab g and I'm going to plug f of x inside of g. So we're going to have function f composed with g of x, and then we're going to grab function g and compose it with f of x. Okay? Is this the last example? I think it is. Oh, no, we have that bottom one. Okay. I don't think what's his face did it. Okay. So then the setup, we're going to grab f first, right? So I'm going to write the cube root of x minus 6 divided by 2. Now, I grabbed f. Now, instead of x, I'm going to put inside of it g of x, which is all of this, right? Does the highlighting help a little bit more for those of you that are still struggling with that? Okay. So then I'm going to have the cube root of, instead of x, I'm going to put my g of x, which is 8x cubed plus 6. And then don't forget the rest of it, right? Minus 6, all divided by 2. So now all I have to do is simplify. So we have, inside we have these set of parentheses, right? But there's nothing to really distribute. So I can go on ahead and just leave the parentheses out and then combine like terms of 6 and negative 6, which is going to cancel out, right? 6 minus 6 is 0. So we're going to have the cube root of 8x cubed divided by 2. So you should hopefully know that 8 is a perfect cube, right? 2 times 2 times 2 is 8. So we're going to have 2 and x cubed and x are also x cubed and the root 8x. The cube root of 8x cubed is a perfect cube. Oh my God. Okay, I'm sorry. I know. That's why it was so weird for me to say out loud. Anyway, so you end up with 2x divided by 2. Well, what's 2 divided by 2? X. So if it works for one, it's more than likely going to work for the other one, but you have to make sure and do it anyway. Okay. So g of f of x, right? So then now, this time we're going to grab g first, okay? And my g is 8x cubed plus 6. Now, inside of this function, I want f of x. So instead of x, I'm going to plug f of x inside of it. So I'm going to have f of x, which is the cube root of x minus 6 divided by 2. Bigger parentheses there, right? And then bring down my 8 and my plus 6. Oh, my bad. Don't forget your cubed right here. Ay, ¿por qué no? There we go. Okay. So what does this do? Well, technically you can apply power of power law, right? So you're going to have 8 cube root of x minus 6 cubed, and then the bottom also has to be cubed. So don't forget you have, why does that not, a plus 6 out here? So we have this cube root and this cube cancel each other out. So we have 8 times x minus 6 over 2 to the power of 3 is 8 plus 6. Well, what's going to happen to these 8s? They're going to cancel out. So you're left with x minus 6 plus 6. Negative 6 and a positive 6 gives you x. So yes, they are inverses for the same reasons as number 10 and 11, but I ran out of room to write all of that. They equal each other. Ay. Damn, that was a loud sneeze.
The teacher's being so loud, man.
Nah, I'm good. Okay. If a function is not a one-to-one, it cannot have an inverse unless we restrict the domain of the function so it becomes one-to-one. That sounded a little weird. Okay, hold on. I forgot to pre-work this one. Give me a few minutes. Okay, so first we're gonna find the inverse function, right? Now, you're gonna notice that if we look at our other examples, for example, number 10, right? We had 1/3 x squared, which is quadratic, but it was an easy quadratic. Why do I say easy? Because you see how we only have an x squared? We don't have an x, right? But if you look at the one I'm giving you here at the bottom, I'm giving you x squared minus 10x plus 5. Okay, so I'm going to show you why this would be hard if I do it the normal way we normally do it, right? So it's f of x. So you don't have to write this part down. I'm just showing you something. So x squared minus 10x plus 15. Okay. If I try doing this the normal way that we just did, right, we would end up with x equals y squared minus 10y plus 15, right? But do you see the problem there? We have a y squared and a y, right? So if I subtract 15, x minus 15, I get y squared minus 10y. I mean, I guess I could factor out a y, but then I would end up with y times y minus 10. There is no way that I would be able to isolate y this way, right? It's kind of weird. It looks funky. So in order to do something like this problem, you would have to complete the square. Do y'all remember how to do that? So we would have to complete the square. Okay. Now, in case you forgot what that was, I don't know. Do any of y'all remember how to do that? Just out of curiosity. We had that amazing lesson done by moi. No, y'all forgot? Okay, cool. All right, so the way we complete a square, right, is that we're going to first put parentheses around the x's. Essentially what we're doing is we're trying to figure out how many units we need in order to complete the square. So we have 1x. I don't have that much room. Hold on. You know what? I think my pen's running out of. So we have an x squared, and then we have negative 10 x's. So let's do those in red. So 1, 2, 3, 4, 5. Remember this? 1, 2, 3, 4, 5. So how many units would I need to complete the square, right? So right here, I would need 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So right here, in order for this to be a perfect square, I would need 25 units. Remember that? So that means that I'm gonna have x squared minus 10x, and I would need positive 25 units. We already have 15. Now remember, this 25, we need to borrow from somewhere, right? You can't just leave them there. So you would have to take them away from what you already have. Do y'all remember that? Is it coming back to y'all? If not, go watch the video again. So then we just simplify, right? So we know that this right here is a perfect square. This is x minus 5, x minus 5. So this part right here is x minus 5 squared because we just made a perfect square out of it, right? Then 15 minus 25 is negative 10. So we now have y equals the quantity of x minus 5 squared minus 10. Do you see how converting it into vertex form makes it a lot more easier for us to find its inverse now? Because now I don't have a x squared and an x. I now have a y and an x. So then now we can do the same thing that we would do before. X equals y minus 5 squared minus 10. And then solve for y. So add 10 to both sides. X plus 10 equals y minus 5 squared. Square root. So we would have the square root of x plus 10 equals y minus 5. And then add 5 to both sides. So y equals square root of x plus 10 plus 5. So that means that the inverse function would be x plus 10 plus 5. So this would be part A, right? Now, let me show you with decimals what's going on. Let me do it from my computer because it's easier for me. Decimals. I want normaldecimals.com. Graphing calculator. Okay, so I'm gonna graph the original, which is y equals x squared minus 10x plus 15. And then I'm gonna graph its inverse, which is, we'll just make it g of x in here, equals the square root of x plus 10 plus 5. Oh, I'm like, I knew that didn't look right. Plus 5. Something looks weird. What is it? So here's 5, negative 10. That's negative 10, 5. Okay, so let me share my screen real quick. I'm recording. My bad. Okay, here we go. Anyway, all right. So when you look at this one, right? So when you look at these two, they're not really inverses of each other, are they? What is the blue missing that the red has? The other half. Now, why is that? Why is it missing that? Oh, because it's a square root. And you can only take square roots of what kind of numbers? Can you take square roots of negative numbers? No. That's why. Okay, so the reason half of it is missing is because you can square a negative number, right? No problem. But you cannot square root a negative number. So these are not official inverses of each other. In order for them to be properly inverses of each other, you would have to restrict the domain of the original, which would be the red one, which is the squared. Okay, well, let's look at their tables because I feel like looking at their tables, it helps us make more sense out of it, right? Than just, okay. So we're going to come here to the settings. Okay, and remember, you can use decimals when y'all are doing y'all's homework or whatever, okay? All right, so right here, for 0, it's 15. So here, I'm going to want to go all the way to 15. And what should I see? Do I see that? No. So from 0 to, so at 0, 15, that's right here, right? This part is not inverse of the blue part. So which part is? So if this left side isn't working, where should it start to work? Do y'all see this dot I just put on here at 5, -10, the vertex? If this is a proper inverse, then what do you think this point is right here? Oh, I'm trying to click it and it won't let me click. Well, do y'all see that though? -10, 5. So do you see how that's inverses of each other? So if I keep going on the right side, so anything greater than 5, right? So let's go to on the original. So here's my original, which is the red one. So at 2, it's -1. That doesn't work because it's below 5. And do you see how it doesn't work here either, right? 2 should be -1. So at -1, it should be 2, and it doesn't work. So when should it start working? Anything after 5. So then if I go here to 5, that's at -10. So 6 should be -9. So if I go in here and I type -9, what should it be? 6, and it is. Okay, so basically what this is saying is that some functions you have to restrict the domain in order for them to be proper inverses. Okay, the reason the left side of that quadratic is not represented is because you cannot square root a negative number. Does that make sense? Okay, so then that means for this problem, we would have to restrict the domain, right? Hold on, let me share my other screen again. Let me stop. I'm not done yet, hold on. I'm almost done. Calma, calma. Be quiet. Okay. So looking at our decimals and looking at the table, because it was a lot easier to see if they were inverses or not, right? And see where like it's supposed to start. For part B, what is a restricted domain? The domain would have to be starting at 5 because 5 was inclusive, right? All the way to positive infinity on f of x. So the domain would have to be restricted on the quadratic in order for this to work. Then you could say they're inverses because you're restricting the domain. You're ignoring the fact that the quadratic function has a left side to it. I know it sounds a little weird, right? But it's like rules, you know? Now, if I didn't say that and I didn't tell you, hey, restrict the domain from 5 to infinity, then they're not inverses of each other. Because you, from the graph, hopefully y'all can see why you have to restrict the domain. Okay, so looking at the graph, hold on, share my screen again. Yes. Okay, so now if you ignore that, I wonder if I can restrict the, I don't want a table anymore. How do I get rid of that? Okay, so if you try really hard and visualize it, right? Do you see how this dot right here that I'm clicking back and forth is reflected across the purple line over here? Do y'all see that? Just ignore all of this on the left. So if you look at this dot right here, 6, -9, do you see how it's reflected across the purple line over here? Any dot I go, right? So like if I go here, it doesn't matter, right? It's reflected. Do you see how like I can go back and forth between the purple dot between this side and that side? Do y'all see that? So if I keep going up here, it doesn't change. If I look at this dot right here, right? Any dot I want, you can go across the purple line and it's reflected on the other side. Do y'all see that? But it only works for the right side of the quadratic function because this left side would technically be negatives and you can't square root negatives. Okay, so hopefully that made a little sense because it does look a little wacky. You just kind of have to like really look at it. I think there's a way I can restrict the domain, but I don't remember how. Anyway. Stop share. Okay, so you have, while I'm recording, so I can tell Okay, so, okay, I guess let me share my screen again. All right. So for week 3, March 8th, March 12th, right? This week. So here's Monday. We just did inverse functions. I will be putting the video sometime soon. I'm going to close it out when y'all leave. Anyway, so you have your lesson 6.6 assignment, which is your quizzes. You have your notebook check, right? And then we have our exam 6B review. I will not be here Wednesday. Depending on how many people submit their review, let's say tomorrow, if I get a good amount of people to submit their review and you tried on it, I will make a video for every single question and you can go and zoom through the questions you needed help on. But if I log in tomorrow and I only see like 5 people do it out of all of my normal kids who usually turn in stuff, oh, I'm not making a video. Y'all can ask me for individual help and I'll answer those. Huh? By when do you have to do it? Or what do you mean?
No. If it's submitted
By tomorrow. I'm gonna check probably like at 7 o'clock or something. I don't know. Deal? I think that sounds fair to me. What do y'all think?
No.
It sounds fair to me. It sounds very fair. Nombre. Okay. Anyway, so that's how that's gonna go. Okay. So try your best on your review. Submit it. If I had enough people do it, I will go on ahead and make a review video for all of the questions, and then you can just kind of click through to the questions you needed help on. And then you will have an exam. So on Wednesday, 6B, I need to have people complete their exam. If you get done with your exam early, which you should, then you are responsible for making sure you're caught up on all of your missing quizzes, notebook checks. Use that time to get that done. If you still have not completed the CK12 credit recovery for first semester, that is due on Thursday at the end of the day. So make sure, I may change it to Friday night, but that's the latest I'm gonna do. Like I'm done. Okay, so get that done literally by Thursday. That's what your deadline is right now. Okay, any other questions about anything? Nah? Okay, let me stop recording.